So today, we're diving into a question that has haunted backyard explorers and confused cartoonists for centuries. What is the actual difference between a reptile and an amphibian? Now, I know what you're thinking. Oh, that's easy. One is slimy and one is scaly, right? And yeah, you're not wrong. But if we stopped there, this video would be like 12 seconds long and my ad revenue would be enough to buy, I don't know, half a gummy worm. So we're gonna do a deep dive and really get into the nitty-gritty. We're talking about skin that's basically a medieval fortress versus skin that's a wet paper towel, eggs that are basically private swimming pools, and why a frog is basically a time-traveling shapeshifter. So grab your metaphorical magnifying glass and let's get into it. Now, before we start pointing fingers and yelling about who has scales, we have to give a little nod to the family reunion where these two groups actually hang out together. Because it turns out that reptiles and amphibians aren't complete strangers. In fact, they share some pretty foundational stuff. For example, they're both vertebrates, so they've got a spine, unlike your local politician. They're both members of the phylum Chordata, which is just a fancy science way to say had a notochord at some point. And here's the big one that gets people lumping them together all the time. They're both ectothermic. That's the $10 word for what we common folks call cold-blooded. But I kinda hate the term cold-blooded because it makes them sound like they have ice water in their veins and are planning to steal the Declaration of Independence. All it means is that they rely on the environment to manage their internal thermostat. If a lizard wants to get warm enough to chase a bug, it has to go sit on a hot rock. They don't have an internal furnace like we do. This is the huge similarity that explains why you see both frogs and snakes, and yes, even turtles, chilling on a warm path at night. But that is where the family resemblance ends, because once you look past the no internal heater thing, these two groups are basically living on different planets. So let's start with the most obvious difference, the skin. Now, I want you to imagine yourself as a reptile. It can be a snake, a lizard, a tiny dinosaur, or a turtle. Now, your skin, as a reptile, is a masterpiece of evolutionary engineering because it's dry, it's tough, and it's covered in scales made of keratin. That's the same stuff your fingernails are made of, which means that if you think about it, a rattlesnake is just a really angry and venomous manicure. And it's not just any keratin. Reptiles, and yes, I'm including birds, are the only vertebrates with a hard structural type called beta-keratin. Mammals like us don't have the genetic recipe for this stuff. That means a chicken's beak and a turtle's scute are made of the same hard stuff, and underneath that hard stuff is a more flexible alpha-keratin that acts like the chainmail in the joints because it lets them bend and slither around without cracking their protective coating. Now, I know what you're thinking, but wait, what about turtles? They don't have scales, they have a shell. And that, my friend, is where you have stumbled upon one of nature's greatest optical illusions. That shell isn't just a rock the turtle picked up at Home Depot. That giant dome and the flat bottom plate are actually made of bone. Modified ribs and vertebrae fused together into a solid tank. And then nature decided that a bone bunker wasn't fancy enough, so it slapped a coat of paint on it. That paint is made of those keratin scutes we just talked about. They are not the shell itself. They are the shell's armored veneer. If you've ever touched a tortoise shell, you'll know it feels like a really thick fingernail material, and that's because it is. It's just beta-keratin sitting on top of a living bone. The skin on a turtle's legs and head is the same dry and scaly reptile skin we've been talking about. So don't let the hard hat fool you. A turtle is a reptile through and through, just one that's really into home security. Now, this whole setup, combined with some fancy lipids, fats and oils, makes reptile skin almost completely waterproof. Think of it like a high-tech Gore-Tex jacket, but it's made of fingernails and bone. This is the key that unlocked the door for reptiles to conquer the desert. They can just hang out in the Sahara, basking in the sun, not giving a single drop of moisture to the atmosphere. Now flip the script and imagine that you're an amphibian. It can be a frog, a toad, or a salamander. Now your skin as an amphibian is a damp, breathable t-shirt. It's thin, it's permeable, and it's usually covered in a layer of mucus to keep it moist. Now, why would you want skin that looks like it's permanently sweating? Well, that's because you breathe through it. That's right, amphibians perform something called cutaneous respiration, which means they literally absorb oxygen directly through their skin and into their bloodstream. This isn't just a neat party trick, because for some amphibians, it's their main hustle. In fact, some salamanders rely entirely on their skin to breathe. Now, the downside of this wet t-shirt of a skin means water evaporates out of it faster than your motivation to go to the gym. If a frog gets stuck in a dry, sunny spot, it'll shrivel up like a sad little raisin. This is why you never find a tree frog in the middle of a parking lot at noon. And this difference in skin isn't just a cosmetic choice, it's a lifestyle commitment. Reptiles chose armor, and amphibians chose a life support system that requires them to live in a spa. And speaking of lifestyle commitments, let's talk about reproduction, because this is where these two groups really show their evolutionary cards, and it all comes down to the egg. Reptile eggs are the Ritz-Carlton of the embryo world. They are amniotic eggs, which is a fancy way of saying they come with a built-in jacuzzi. Inside that leathery or hard shell, there's a membrane called the amnion. This creates a self-contained little pond for the baby reptile to float around in while it grows. And because of this incredible invention, reptiles can drop their eggs off on dry land, in a hole, under a log, or on a sandy beach, and just say, "Good luck, Junior, don't get eaten by a seagull or a raccoon." And when that baby reptile hatches, it looks like a perfect tiny replica of its parents. A baby turtle looks like a turtle, and a baby snake looks like a snake. There's no awkward teenage phase where it has gills and a tail fin. Now, amphibian eggs are, well, basically jelly beans. They're covered in a gelatinous goo that has to stay wet, or else the babies inside become dust. This means that amphibians are still tied to the water, because without it, they can't reproduce or just survive in general. Now, when that egg hatches, it doesn't look like a frog, it looks like a weird little fish with a big head and a tail. We call this thing a tadpole. It breathes with gills and swims around eating algae, and then it undergoes metamorphosis. That's a fancy word for completely rebuilding your body on the fly. It grows legs, absorbs its tail, loses its gills, and sprouts lungs. It is literally a shapeshifter. And just when you thought you had this reproductive thing figured out, Mother Nature goes, "Hold my primordial ooze." Because not all amphibians follow the script. Some of them are absolute rebels. For example, take caecilians, which are weird, limbless amphibians that look like giant earthworms. Some species, like Siphonops andilatus from Brazil, actually produce a fatty, nutrient-rich milk from their skin and feed it to their babies. And some even give birth to live young. And it's not just some caecilians, because a few species of toads have said forget the egg and tadpole stage entirely and just give birth to fully formed miniature toadlets. This is called vivigory, and it's so rare that fewer than 1% of all frog and toad species do it. So while the classic story of eggs in a pond is the norm, the amphibian world is full of bizarre, rule-breaking parenting styles.
But now that we've covered the outside and how they make more of themselves, let's pop the hood and look at the engine, specifically the heart and lungs, because even though they're both sitting on the same branch of the vertebrate family tree, their internal plumbing tells a story of two very different lifestyles. So let's start with breathing. Reptiles can't breathe through their skin, so they rely entirely on their lungs. And these aren't just sad little sacs. Reptile lungs are actually pretty complex. They have folds and partitions in them to increase the surface area for gas exchange, which makes them much more efficient than amphibian lungs. Some reptiles, like crocodilians, have even developed a muscular diaphragm-like structure to help them pull air in. In turtles, yeah, they have a breathing problem that is uniquely their own. Because their ribs are fused into that giant bony shell we talked about earlier, they can't expand and contract their rib cage to breathe like we do. Instead, they've evolved special muscles that act like a bellows, pushing air in and out of their lungs by moving their internal organs around. Amphibians, on the other hand, are a bit of a mess. They have lungs as adults, usually, but they're kind of weak and pathetic and not that great at their job. That's why they rely so heavily on that whole breathing through their wet skin trick we talked about earlier. Now we have to talk about the heart, because both amphibians and most reptiles have a 3-chambered heart, 2 atria and 1 ventricle. But don't let that 3 number fool you, because the way they use it is totally different. In amphibians, that single ventricle is basically a lazy river with some strategic dividers. Oxygen-rich blood from the lungs or skin and oxygen-poor blood from the body take a ride through the same chamber, but due to some clever internal architecture and timing, they don't mix into a completely useless smoothie. It's more like they're two different colored streams of water flowing side by side. It's not the high-performance fuel injection of a mammal, but it's also not total chaos. It gets the job done for an animal that spends a lot of time sitting still and breathing through its skin. In reptiles, including our turtle friends, there's a partial wall, a septum, inside that ventricle. It acts like a lane divider on a highway because it keeps the oxygenated and deoxygenated blood mostly separated. Now, full disclosure for the nitpickers out there is still a little bit of mixing that happens, especially when the animal is diving or holding its breath. The real magic trick reptiles have isn't just the wall, it's the ability to actively reroute blood flow and bypass the lungs entirely when they aren't breathing. Amphibians can't do that whole plumbing maneuver. Now, crocodilians, being the overachievers of the reptile world, actually have a full four-chambered heart, just like us mammals and birds. But even with a four-chambered heart, they've got this special valve called the foramen of Panizza that lets them choose to mix their blood when they're diving deep underwater. That's why a crocodile can explode out of the water with the speed and power of a scaly torpedo, or stay submerged for hours like a log with bad intentions. So while they might look similar from the outside, the internal plumbing of a reptile is just a bit more high-tech. But let's zoom out and look at the big picture of how we got here, because this whole scaly versus slimy thing isn't just a fun fact for trivia night, it's the result of one of the biggest moments in the history of life on land. So imagine Earth about 370 million years ago, during the late Devonian period. The land is a vast, empty landscape of rocks and ferns, and crawling out of the water for the first time are our heroes, the first amphibians. They were the original pioneers, the Neil Armstrongs of the vertebrate world, taking those first awkward, belly-dragging steps onto dry land. For tens of millions of years, they ruled the swamps, but they were, as we've established, tied to the water for reproduction and survival because of their jelly eggs and damp skin. But evolution is like a tinkerer in a garage because it keeps fiddling with things. So from one group of these ancient swamp-dwelling pioneers, a branch of the family tree we call the reptiliomorphs, a revolutionary innovation appeared around 315 million years ago, which is the amniotic egg. This was the biological equivalent of inventing the Ziploc bag, because suddenly animals could reproduce without being chained to a pond, and they could explore the dry interiors of the supercontinent Pangaea.
Now, this is where you need to pay attention, because the family tree gets messy. Those first amniotes were the very first reptiles, and that other famous group of ancient amphibians, the temnospondyls, didn't lead to lizards and turtles. They're actually the weird uncles that eventually gave rise to the modern frogs and salamanders in your backyard. That's right, the lineage that stayed in the puddle is more closely related to that ancient group than the lineage that conquered the desert. Why? Because evolution is less of a straight line and more of a drunk man trying to walk home. Now, this evolutionary split was huge, as you can imagine, because it allowed reptiles to diversify into everything from tiny geckos to monstrous dinosaurs. Amphibians, meanwhile, were stuck with their water. And you know what? It worked for them, because they've been around for over 370 million years. They survived the asteroid that wiped out the dinosaurs. It's not that one is more evolved than the other. They're just two different and incredibly successful blueprints for being a vertebrate on planet Earth. Okay, we've covered the what, the how, and the why, so you're now basically a certified herpetologist. But before we wrap this up, let's talk about something that doesn't get nearly enough attention: how these critters actually see, hear, and taste the world. Because the differences between reptiles and amphibians go way beyond skin deep. So let's start with the eyes. Next time you see a snake, notice that it doesn't blink, because it can't. Reptiles have a transparent scale called a brill or spectacle covering and protecting their eye. Even turtles have a version of this. They can blink, but they also have a tough, clear scale protecting their eyes.
Amphibians, on the other hand, can blink. In fact, frogs use their big, bulging eyeballs to help them swallow. That's right, when a frog swallows, its eyes retract into its head to help push the food down its throat. So the next time you see a frog blink, it might just be swallowing something. Then there's the hearing. Most amphibians have a visible eardrum called a tympanum right on the side of their head. You can see it as a big, flat circle behind their eyes. Reptiles, including turtles, usually have their ears tucked away deeper, often covered by scales. They can hear, but they're not exactly out here listening to high-fidelity jazz. And finally, let's talk about smell. See, snakes and lizards have a superpower called the Jacobson's organ, or vomeronasal organ. It's a special sensory patch on the roof of their mouth. That's why you see them flicking their tongues out. They're not being rude, they're literally tasting the air. Their tongue collects scent particles and brings them back to this special organ to get a 3D smell-o-vision of what's around them. Now turtles, they're the exception to this superpower. They didn't get the memo on the whole Jacobson's organ thing. They smell the old-fashioned way, by using their nostrils like the rest of us. Most amphibians don't have this fancy gear either. Their sense of smell is more basic, good for finding a mate or a meal, but not nearly as high definition. So even in the realm of the senses, it's a completely different set of hardware running the show. Alright, with all of that out of the way, let's do a quick summary, just to make sure all that gooey knowledge sticks in your brain. Reptiles have dry and scaly skin. Amphibians have moist and permeable skin. Reptile babies come out of a private pool egg looking like a tiny adult. Amphibian babies come out of a jelly bean looking like a fish and then goes through metamorphosis. Reptile lifestyle is I can live anywhere I want. Amphibian lifestyle is I am legally required to stay within 50 feet of a puddle or I will cease to exist. They both can't regulate their own body heat, so they both love a good sunbeam, but the amphibian has to make sure that sunbeam is shining on a damp leaf, or else it's a recipe for jerky. They are cousins, sure, but one is the cousin who went off to conquer the land and the sea, looking at you, sea turtles, and the other is the cousin who stayed home to tend the swamp garden. Both are crucial, both are fascinating, and both are way cooler than that plastic toy you thought was a dinosaur when you were 5. So, that's it. That's the difference between a reptile and an amphibian. We went from slimy versus scaly to amniotic eggs, pulmonary circuits, and amphibian shenanigans. My brain is officially full, so now I'm going to go sit by a pond and contemplate whether I'm more of a reptile person or an amphibian person. But with that being said, you can do the things other YouTubers ask you to do. It's your choice, really. Thanks for watching.